So in the previous videos, we've looked at how we can load an image into our program and display it. Now we're going to learn how we can get pixel information from that image. This is important when we want to manipulate the images or create generative portraits with them. So let's start from the code we had written in the previous video. You can find the code for that in the description below. Now in this code, we've already loaded an image. We've stored it into a variable called cat image, and we're displaying it over here in raw. Now this variable cat image contains all the information we need about the image. It tells us the size, meaning how many pixels is it. Pixel refers to the smallest unit on a computer screen, and images are also made up of them. So we usually refer to the image by the number of pixels it contains and the width by the number in the height. So this image over here would be a 400 by 400 pixel image. Now each of these pixels contain information about the color that it is. So it contains the RGB and brightness value of the pixel. Now how do we get the color information of, let's say, this top left pixel over here? To do that, we can say cat image dot get 0, 0, because 0, 0 is the top left point over here. So let's just print that value and see what it gives us. So within draw, I'm going to say cat image dot get 0, 0, and let's store this value in a variable called color. So we'll say color equals cat image dot get 0, 0, and we will print this color. Okay, so when we print it, it's giving us 4 numbers here: 125, 69, 20 and 255. So the first 3 are the red, green and blue values, and the fourth one is the brightness. You'll notice that this is being displayed in a square bracket. This is known as an array. An array essentially refers to a list of values stored as a single unit. So in this case, let's say you want to access just the red value and you want to print just the red value over here. You will need to access them by their individual position. So as you can see, 125 is of position number 0, 69 position 1, 20 is position 2 and 255 is position 3. In computer science, counting starts at 0. So we do 0, 1, 2, 3 and not 1, 2, 3, 4. So let's say we want to print only the red. Then instead of printing color, which is an array, we will print color of 0. And the position goes in these square brackets over here. So that it's printing only the red value now. Let's say we wanted to print only green, we'd have to say 1. And only blue, we'd have to say 2. Now we have some very valuable information about the image. We can actually access the red, green and blue and the brightness value of every pixel. So let's make a simple application using this, such that when we move our mouse over an empty canvas, an image appears. So let's modify this code to maybe print the color value of wherever our mouse is. So for now, let's just go ahead and print color, the entire array, and not any individual value from it. Okay. Right now we're getting the value from 0, 0. What if we get the value from mouse x, mouse y? So we're moving the mouse along the image, and as you can see, it's showing us different values because of that. But since there's too many values, it's difficult to make out from the noise. So I'm just going to move this to function mouse pressed and just move this part over here. We can remove it from draw. So now we'll print the color only when we press our mouse on a particular point. So when I click my mouse near the black, you'll see that it's a value that's close to 0, 0, 0. And when I click on the white part, it's a value that's closer to 255, 255, 255. So great, we now can actually get the color of wherever we're clicking the mouse. So let's move this back to draw since we've seen the values. And instead of printing the color, let's actually draw an ellipse at mouse X, mouse Y of that color. So we'll just make the fill color. Okay. So now we have like this magnifying glass over here so that we can see what color is there below our mouse pointer. Now let's see what happens when we remove the image. What if we stop displaying the image? So we still see the colors behind, but we don't see the image itself. That's because cat image contains all the information of the image, even though it is not displayed. So that's why we're seeing these colors over here. So lastly, let's just move background to set up so that the background gets drawn only once. And now what happens is we can sort of see this image appearing over here. Let's make a few changes to the ellipse we're drawing. Maybe let's make it 20,20 and let's remove the stroke. And now if we go slowly enough, we can actually make our cat appear over here. So we can even make this a bit smaller. And as we move our mouse, we can have the image of the cat appear. Now we can change the image based on what we want to appear. Maybe you have a secret message hidden over here, and as you move the mouse, you want somebody to discover the message. Now if we make it smaller, as you can see, if we make the ellipse smaller, the image has much more clarity than it did before. And just to make it easier to use, we can move this entire part into function mouse dragged so that it gets drawn only when we drag our mouse and not when we move it. So this way we can actually have more control over what parts we want to expose. Let's say we only want the eyes of the cat to be drawn. We can sort of control that over here now. Like this. So go ahead and play with this. The most important takeaway from this video is that now we can access the color of every pixel, and we can even access the individual red, green and blue values. And we're going to be using these concepts to learn how to make generative portraits. So see you in the next video. Thank you.